Here they're asking us to find vertical plus horizontal asymptotes. Remember what happens and what we need to do. For vertical, we have to set x squared minus x to the fourth not equal to 0 and find limits. For horizontal asymptote, the only thing we have to find is the limit of y as x approaches infinity and negative infinity. This is what we need to do. For vertical asymptotes, we have to set that the denominator cannot equal 0. And if we find values for which the denominator is 0, then we have to find limits, left and right. For horizontal, it's easier. All we have to do is just find the limit as x approaches infinity or negative infinity, or both. In this case, because it's a simple or pure rational function, both will be the same. So let's go ahead and just do this first one as limit as x approaches infinity from 1 plus x to the fourth over x squared minus x to the fourth. Yes, when you plug in, this is infinity, this is negative infinity, the sign is not important, there is hope. Degree of the top. And yes, so x to the fourth comes out. Degree of the denominator.
Would be x to the power 4.
Very good. Awesome. I need two terms and two terms. At the top, one with positive, and the denominator, one with negative.
For the top one numerator, it would be 1 over x to the power 4 plus 1.
Excellent.
And then the denominator would be 1 over x to the power 2 and 1.
Excellent. I was dying to do this. That was my purpose. Gone. Now I want to know where this is going and where this is going. Again, when x approaches infinity or negative infinity. Otherwise, the answer will not be that. But the answer is that because of this. Anyone?
That's 0.
Awesome. Well done. So therefore, the limit is
-1.
-1. It's the same for both. I will have to write y equals -1 horizontal asymptote and nothing else. So this is done. So for horizontal, that's all I need to show. Find the limit at infinity and negative infinity. It's a rational function. I don't need both. I only need one. Now, let's talk about vertical. I have x squared minus x to the fourth equals 0. I highly recommend arrange it in descending order and also multiply by -1 because it's not in descending order and it has a negative leading coefficient. If you ever give me an equation to solve and it has a negative leading coefficient, I will say, I refuse to solve with a negative leading coefficient. I refuse. So I'm going to multiply by -1. And only then I factor out x squared. I get x squared minus 1. And I continue factoring. I have degree 4. I need 4 solutions. Degree 4 means 4 solutions. Hopefully they're all real. I don't care. But I have to find 4 solutions. So x squared, x plus 1, x minus 1. So I have 2 x equals 0, 0 twice, x times x. I have an x equals -1, and I have an x equals 1. So, because nothing in the denominator can be simplified with the numerator, all these three are vertical asymptotes, guaranteed. X equals 0 is a vertical asymptote, x equals -1 is a vertical asymptote, x equals 1 is a vertical asymptote. No factor will be simplified with the top. No whole, because no factor goes away. And we are forced at this point to determine all those limits. Just the fact that I'm saying x equals 0 is a VA is not enough. I have to find the limit as x approaches 0 from the left. The limit as x approaches 0 from the right. And then that is complete. Again, because these limits will be infinity or negative infinity, we'll check in a moment. That's why this is a VA. So, with 0, the top is 1. With 0, this is positive, but this is negative. So positive and negative. And this is always positive. So the denominator is 0. So I have positive at the top, but I have negative in the denominator, so this is clear. With 0 from the right, this is positive, this is positive, this is positive, but this is negative. So it's also negative. Both of them are negative. And I have to repeat for +1 and -1. So for x equals 1, VA, and show the two limits, and x equals -1, VA, and must show the two limits. Both of them have to be some sort of infinities. Otherwise, they will not be vertical asymptotes. Any questions? Any questions on a function and finding its vertical and horizontal asymptotes? Horizontal is always easier, I would say, than this, because it's less work. Finding the points at which the function is undefined and there is no simplification going on, so it's no whole or removable, then we have to identify the vertical asymptotes and also have to determine each limit. Okay, any questions? Any questions? Okay, I don't want to forget to talk about test 1. We are not there yet. Right? We still have to finish 2.7 and 2.8. These are the last two sections of chapter 2. I know I'm not going to be able to finish them in 20 minutes. It's not possible. So the test cannot be next Wednesday because I use an entire session to review. So test 1 next Monday, the following Monday. I have no idea what that day is. Is it October already, or what is it? I'm looking at my phone.
October 2nd.
Thank you very much. Thank you. So you will also have that weekend to study. So I have to finish 2.7, 2.8 today and Monday. We are going to use next Wednesday the entire time to review, and then the test is the following Monday. Sorry, I know I'm slow, but I can't. I have to discuss these topics with you. I just can't. Okay. So for the next 20 minutes, let's discuss 2.7, 2.8. We're not going to be able to finish. I know that.
I had a question regarding the test.
Yes, I'm ready.
Is the deadline for the test Monday, or I know the testing center is open like some weekends. I think it's only like 1 or 2 weekends a month, but like if we
Yes,
could take it,
if you want to take it early, it's always possible. Let me look. I have my calendar.
like could we take it anytime after class that Wednesday that was originally the test, as long as it happens before class the Monday
So
of the week?
Wednesday the 27th. It's not open on the 30th. It's not. I'm looking at the calendar. The testing center is not open on the 30th. But
Okay, what about
you
like
can
that
take it on the
Thursday?
you can take it on the 29th on Friday if you want. Sure. But
Okay, so it doesn't have to be taken on Monday the 2nd if we would like
but
to
it
take
cannot be later than that.
Right, okay, but after the
Yeah.
review on Wednesday, if we wanted to
Yes.
do it Thursday or Friday.
Yeah. Just let me know if that is the case.
Okay, thank you.
Thank you. So we talked about two major concepts. Two major concepts so far in this class. Can anyone help? Which concepts? Big concepts. Over and over and over we discussed that.
Limits?
Yes, of course. So this is one major concept. I tortured you with limits for 3 weeks. 2 weeks. What else? And we looked at several functions and we calculated it and fully simplified it. We looked at quadratic and rational and radical functions, and we determined that for all those functions and simplified it fully. Difference quotient. Anyone remembers it? Anyone?
F of x, or sorry, f of x plus h minus f of x, all divided by h.
That's it. These were the major concepts that we looked at. Yes, and other things with the asymptotes and so on and so forth and indeterminate cases, but these two were the big concepts. We're going to put these two together. A while back I said that this is almost the instantaneous rate of change, or almost the slope of the tangent at that point. But now I'm not going to say almost anymore. I'm going to say it is exact. So both concepts together both concepts together give us a new super concept. Super concept. So both concepts together give the derivative function. And you can say, what is that? What does it mean? What are you trying to do? I will explain everything, but let me write it first. So f prime, we read this f prime is the limit as h approaches 0 from f of x f of x plus h minus f of x divided by h. And you're going to say, I don't understand what you're talking about. What is this word? What does it mean? And I will explain before we even look at the definition. So let's look at a few graphs first. Here's one graph. Here's another graph. Here's another graph. This is called a cusp right here, like between two teeth. This is called a corner. And just one more. So we notice here that we have 5 different situations. In the first situation, would you say that this is a continuous function?
Yes.
Continuous, very good. Would you say in number 3, I specifically intentionally jumped over that for a moment. Do you think that, would you say that this is continuous? Is this function continuous?
That looks like 2 functions.
Good. Yep. Is this function continuous?
Yeah.
Very good. And this one, last one, is this continuous?
Yep.
Very good. The only one in my exam, in 5 examples, this is the only one that is not continuous. Okay, stay with me, please. Now, on this continuous graph, at any point, can I draw the tangent line? Can I? Was I able to draw the tangent line at any point I wanted? Yes? Correct?
Yes.
Yes. What about here? For this function that is not continuous. Here I cannot. The tangent has to be unique. One tangent. Here I can. Here I can. But at this point, I have a tangent here and a tangent here. So everywhere I can determine the tangent or draw the tangent and find its slope, but not at this point. So we will say that this function is not differentiable. At, I'm going to put here A, at A. What does that mean? It's a fancy word, not differentiable. What does it mean? It means that at this point, it does not have a unique one. It does not have a unique tangent. It does not have a rate of change, in other words. Not differentiable. It does not have a rate of change. No rate of change at that point. It has a rate of change everywhere else, but not at this point because it's not continuous. This one is differentiable everywhere. At any point on the graph, you can ask me, find the slope here of the tangent. And I'll say, yeah, I think it's about 2 or maybe 3. Here, I'm going to say the slope is 0. I'm going to say here the slope is 2. Because I draw a triangle, a right triangle, and I can determine the height and the width, or base times height, base and height. So this is differentiable everywhere. It's continuous. And it does not have a cusp, it does not have a corner, and it does not have a vertical tangent. So again, this repeats in the other 3 situations. So here, it's a vertical tangent. And we know that the vertical tangent has no slope. It's undefined. Vertical tangent, no slope. So at this point, the function is not differentiable. It does not have a rate of change. It has a rate of change everywhere else, but not at this point. Again, here it does not have a rate of change because one slope is on a negative on this side and another slope is positive on this side. It's not a vertical tangent, but it has 2 tangents. And you cannot say, well, why don't you draw this? No, the tangent has to follow the function. Follow the function, tangent. Follow the function, tangent. Follow the function, tangent. Okay, not here or here. That's not possible. So a function has a rate of change if it is continuous at every point. If it is continuous but does not have a cusp, a vertical tangent, or a corner. So we say, and here's a question for you. Continuity implies differentiability. Both or only in one direction. Double equivalency. This implies this. This implies this. Option 1. Option 2. Continuity implies differentiability. And option 3. Differentiability implies continuity. I will give you. Yes, go ahead.
If your differentiability only implies continuity?
Absolutely. This is false. This is false. Absolutely. Thank you. If a function is differentiable everywhere, it must be continuous everywhere. If a function is continuous everywhere, it cannot necessarily, if a function is continuous, it may not be differentiable. Where? Aha. Continuous, but it has a cusp. Continuous, but it has a corner. Continuous, but it has a vertical tangent. In these 3 situations, that's why continuity doesn't always imply differentiability. It implies differentiability as long as these 3 situations don't happen. So that's why differentiability guarantees that the function is continuous. So I printed out for us to work on 2 examples, but we're not there yet. So I'll work on this with you next time. But I know we have a couple of minutes, but I just wanted to go back to the book. I'll stop in a couple of minutes, I promise. And I just want us to look at a graph. We're not ready for definitions and stuff, not yet. So this is what I printed out for you. To work on. Okay. So here's the question. We're given a roast turkey is taken from an oven when its temperature has reached 185 degrees. Here it is, 185 degrees. And it's placed on a table in a room where the temperature is 75 Fahrenheit. So of course the temperature decreases with time till it gets to the room temperature. It cannot be lower. If the room temperature is 75, it cannot go to 65. Okay, so the graph shows how the temperature of the turkey decreases and eventually approaches room temperature. By measuring the slope of the tangent, estimate the rate of change of the temperature after 1 hour. Okay, so in order to determine the rate of change, which is how fast the temperature is changing at 60 minutes, by measuring the slope of the tangent, so the red line is the tangent, estimate the rate of change of the temperature after 1 hour. At this particular instant, instantaneous rate of change. Okay, so how will I do this? I will extend this line till it hits here, and I'm going to read. It's not easy to estimate, but we can. So if this is 100 and this is 150, imagine that I'm extending this to roughly, this is 185, they said. So here, maybe 150 is here, 175, roughly in the middle. Okay, so 1 point is 0, 175 degree Fahrenheit. And then I'm going to try to extend this and try to read it here. But this may be too much. So I'm going to read it here, right here. I'm reading a point between 120 and 150, so 20, 30, 40, 50. So I'm going to say roughly 130. So 130, and this is 75. So 130, comma 75. Again, I'm reading 2 points. 0, comma 175, and 130, comma 75.
I have a question.
Yes?
With that second point, could you go back to the graph really quick?
Yes.
Is there a reason that you chose that and not a point that was easier to read, say maybe like 90? Like, can you choose any 2 points on the
Any
line?
2
Like,
points, doesn't matter the slope. If I hike a mountain and I choose these 2 points to determine the slope of the mountain, or I choose this point, these 2 points to determine the slope of the mountain, it won't matter.
Right. So we don't.
You don't have to stick.
For both of them, you extended the line, but we could have just chosen 2 on the line.
If I'm trying to determine 2 points that are easy to read, that's all. So 75 minus 175 over 130 minus 0. So the numerator is negative 100, the denominator is 130. So whatever that is, that will be 2 measurement units. The numerator is degree Fahrenheit. The denominator is hours. Actually minutes. I'm pretty sure that's, let's look carefully. Yeah, minutes. Okay, so degree Fahrenheit per hour. So at that moment, at P, the instantaneous rate of change, how fast is the I was trying to find my calculator, and here it is. So how fast is changing? So 10 divided by 13, roughly by negative is 0.77 degrees per minute. That's how fast it's decreasing its temperature at that moment. Is this perfect? No, it's an estimate. It's an estimate. Definitely has to be negative. The slope is negative. And we know that because it's decreasing. So I will stop here.